What is projectile motion? It is any motion of a body in free flight. In dynamics, problem statements usually require determining time, position, velocity, or acceleration. How do we go about solving projectile motion problems? Projectile motions in dynamics, we'll limit it to 2 dimensions. So we have an equation that describes the motion in the x direction, and we actually have 3 equations that describes the motion in the y direction. So let's number these. So we have equation 1, equation 2, 3, and 4. However, this 4th equation was derived using equations 2 and 3. So for the y direction, you can only choose 2 equations. You can't use all 3. Out of these 4 equations, we have 3 equations possible that we can use. What this means is that at most, you can only have 3 unknowns. Let's take a look at some of these problems. We have a cannon here, and it's going to fire a cannonball, and it'll have a projectile motion, such as that. We'll have a soccer player who'll kick the ball up a hill, and it'll have a projectile motion as such. And a football player tries to make the goal, and it just makes the goal. And we have a skier, he's going to go down the slope and have a trajectory as such. Before we start analyzing these 4 problems, we need to specify a coordinate system where x is defined to be positive to the right and y is defined to be positive upwards. We'll identify each starting point as A and each ending point as B. So that will be A, that'll be B, and this will be A, and that'll be B. So all these problems are more or less the same. The problem statement will usually give us some kind of angle, and we can determine, or we can write an expression for the x component in terms of the overall velocity of the cannonball, which would be VA cos theta. And we can do this for each one of these problems. So, and its y component will be VA sine theta. Likewise, that's the initial velocity, and its x component is again VAX is VA cosine theta, and the y component would be VAY VA sine theta. And we continue this for all the problems. It really doesn't matter what the object is. All it matters is that each of these problems assumes a projectile motion and they are in free flight. You have to recognize that the velocity in the x direction never changes. Okay, velocity in the x direction never change. So why is that? Well, that's because in dynamics, we assume even a cannonball, which in real life is large, we assume it to be a particle. We assume the soccer ball, right? We assume the soccer ball, although it's big in real life, again, we assume it to be a tiny particle. And likewise for the football, we assume it to be a particle. And the skier, who is very large, we assume him or her to be a particle as well. So since we're assuming that each one of these large bodies is a particle, then the effects of drag is very negligible. We can conclude that the velocity in the x will always be constant. And it will always equal to its initial velocity in the x direction. So what about the y direction? The velocity in the y direction will change. That's because there are effects of gravity. Effects of gravity is always present. Therefore, velocity in the y will change.